Hey there. So let's do another video for business analytics. Let's this time look at pricing optimization. So in this situation, what we're trying to do is use price as a tool to optimize something like our optimal level of sales or optimal level of revenue. And later we'll take a look at optimizing profit. In this case, we start from the assumption that a demand model has been made. And from that demand model, we have a couple of parameters. We've got the intercept of 85, meaning roughly that at a price of 0, we can envision that we would sell 85 units. We could give 85 away. With a slope of negative 3.5, and that slope tells us that for each additional dollar we charge, we'll sell 3.5 fewer units. So we have a couple of steps. The first step we do is we estimate demand. And I'm going to call that estimated demand. Fancy that. It's a good name for estimated demand. And then the second thing we're going to calculate is revenue. And then we will use these two things. First, to estimate demand at each price. And then we'll look at which prices will maximize revenue and which prices will maximize sales. And actually, I'm going to change this number 1 really quickly. I'm going to say estimate demand and revenue at each price. So to estimate demand, we're going to just use that simple intercept slope equation, right? Y equals mx plus b. And in this case, demand is our y variable. It's the thing that we're interested in estimating. And our demand is going to be equal to mx plus b. And our slope is m times our price, which is x. And then we add our intercept, which is b. Because we want to drag this formula down to fill all these cells, I need a couple of absolute references. One is basically on anything that is fixed, right? The slope and the intercept. So I'm going to use Command T on both cells that I've referenced in column G. If you're on a PC, you can use F4, and if that doesn't work, you can enter those dollar signs manually. This number, it's coming up as $1, but it's not actually. So when I drag these down to estimate demand, I'm going to change these from accounting to number. So what this is saying is that at a price of $8, I think we're going to sell 57 units, right? Which is equal to 85 units minus 3.5 for each dollar we're charging. To calculate our revenue, we're going to use a basic formula that revenue's price times the number demanded. So if we charge $8 and we sell 57 units, our revenue is going to be $8 times 57 units, otherwise known as $456. And we can drag that down as well. The interesting thing with revenue is that there's a trade-off. At each additional price, right, as we go from $8 to $8.50 to $9 to $9.50, we're getting more in revenue per unit. At the same time, the number of units we sell falls, 57 to 55.25 to 53.5 to 51. And so revenue will increase for a little while, but after a while it reaches its maximum, and then it starts to fall. So the quantity that maximizes sales and maximizes revenue, those are going to be different. We can eyeball these and see that at the lowest price, our demand is the highest, but we have another option, and that is a conditional formatting option. We can ask Excel to automatically change the formatting of a cell that meets a certain criteria. So under conditional formatting, which is under this Home tab, you have a lot of choices, and I'm going to choose top-bottom rules, and then more rules. And I'm just going to say that I want it to format the top or bottom ranked values, and in this case, I just want the top 1 value to be formatted automatically. If you're on a PC, you'll have to tell it how to format it, but Excel and Mac just gives you this option. And if I hit OK, the 57 is highlighted, right? This just says that Demand is highest, number of units at the lowest price we could charge. Revenue is going to be different. If we highlight all these and look at conditional formatting, same thing, top-bottom rules. Wanting to see just the largest or the top value, we're going to see that revenue is highest at $516. At prices above $12, revenue falls, and at prices below $12, revenue falls. So if we're trying to identify the prices that will maximize revenue or maximize sales, those are two different prices, right? If we want to sell the largest quantity, that's going to happen at the lowest price. It would be a price of $8. Whereas if we want to have the largest amount of revenue coming in, that's money coming in before costs are taken into account, we're going to want to charge $12. So what I'm going to do is just insert a little text box and answer a couple of questions. The first one is that if the company is interested in selling the most units that it can, it's going to charge the lowest price possible, right? In this case, $8. Right. The second one is that if the company's looking at maximizing their revenue, they want to bring in the most money that they can, they're going to want to charge a price of $12 to maximize their revenue at $516. And that's all we're going to look at in this model, is just how we can use demand model parameters from a linear demand equation. You can see another video if you're interested, to estimate demand at a series of prices. And then we can calculate the revenue based on the prices and demand that we forecasted. And then we can just estimate what's going to bring us the largest quantity demanded versus what's going to bring us the most revenue. All right, that's all I have for you today on this video. Happy calculating.